So here we are, part 5. All right. So it looks like we have some work about parallel and perpendicular lines. Let's see. Has some distance formula and some midpoint work. So let's jump into this first. Slopes of parallel and perpendicular lines. And so let's first establish the rule so it'll be easier down the road to fill in this chart. It might go a little faster. So parallel slopes are equal to one another. Perpendicular slopes are opposite reciprocals. Okay, that's messy. Try that again. Okay, so parallel slopes are what we call opposite reciprocals. Which is just a really fancy way of saying that we're going to flip the fraction and change the sign. I'm not going to go into detail why this rule exists. I'm just going to simply use it as a rule. If you want to know more, just ask your teacher. I'm sure they'll be more happy to explain in detail why this rule exists. But either way, if slope of line A is 5, the parallel slope should be 5. Perpendicular slope should be 1/5, negative 1/5. Because again, if we're taking the opposite reciprocal, if we start with a 5, which is really 5 over 1, we're going to flip that around to a 1/5 and then change the sign. So if it was positive, now it's going to be negative. So parallel half, perpendicular negative 2. So negative 3/2, positive 2/3. Negative 7 for parallel, it'd be 1/7. Flip it around, change the sign. That's a 7, I think. Ooh, got worse. Parallel to 4/3 is 4/3. Perpendicular is negative 3/4. Okay, so let's go on to this next part. AB has a length of 5 and a slope of negative 3. If figure ABCD is a rhombus, what is the length of the slope CD? Okay, so I don't know about you guys, but I'm a very visual person. I need to draw this thing out. So this might not be to scale, but I'll do my best. So let's say you start with A, slide down to B, now we're at C, D, and back to A. Now again, this isn't to scale, this is just to kind of give me perspective on where the pieces are. So this says it has a length of 5, we're talking about AB here, and a slope of negative 3. So that's 5, and then M equals negative 3. If it's a rhombus, what's the length of CD? Length and slope of CD. And so now that I drew my picture, I know that we're talking about this part. And so that tells me a couple really important pieces of information. First of all, I know that the length of CD, so like CD has to be 5, and the slope of CD, now knowing that this is supposed to be a rhombus, it's horribly drawn, but it's a rhombus, these are parallel, which means they have to have the same exact slope, so the slope is going to be negative 3 as well. And so again, pro test taking tip, draw everything out. Don't try just to see it in your head, like actually draw the thing out. It takes 2 seconds and then it's much easier. Let's move on to midpoint. So find the midpoint of 1, 2, and 3. So let's establish first the midpoint formula. The midpoint formula is just like the literal middle of 2 points, so it's kind of just taking the average. And so if you want the x value of the midpoint and then the y value of the midpoint, that is exactly the same as averaging your x's together. That's what the middle. That's how you find the middle of things. That's when to measure the middle, if you will. So if you average, you're going to add the x's together. That is an add, divide by 2. And so if you want the y coordinate, we're going to do the same exact thing, y1 plus y2 divided by 2. And so that's what we're going to see in action over and over again here. We're just going to be averaging our x's and y's. So if I want the x value of the midpoint, I'm going to be adding my x's together. So it's going to be 6 and a negative 5. Divide that thing by 2. If I want the y value, I'll do the same thing. So I'll take that 4 and then add the negative 1, divide that by 2. So 6 minus 5 is 1 divided by 2 is 0.5, or just 1/2. I think I'll go ahead and write it as a 0.5. 4 minus 1 is 3, divide that by 2. You get 2/3, or I'm sorry, 3/2, which is about 0.67. That's an approximation. If you want to keep it as a fraction, which is honestly my preferred way to write it, we're looking at 1/2, comma, 3 over 2. All right, so let's keep that going. I'm probably gonna drop the color scheme thing because it's starting to get a little tiresome, but I'll just switch to nice blue. So if we want to find the x midpoint, y midpoint, we're going to add our x's together. That'd be 10 and 9. Divide by 2. Then add our y's together. Now, if you're wondering why this writing is a subtraction problem, of course you know that if you add and subtract those two signs together, it becomes just a negative, hence a subtraction problem. I don't think we need to see the whole thing, so I'm just kind of skipping to the end. 10 plus 9, excuse me, is 19. Cut 19 to half. Let's see, what do you get? 9.5. Okay, so we have 1 minus 4 to be 3, so that'd be 3/2. Let's see, switch to red. All right, last one. Let's add our x's together. So that's negative 5 plus 8 divided by 2. Then let's average our y's together. 6 minus 4 divided by 2. Negative 5 plus 8 should give me a 3, so that'll be 3/2. 6 minus 4 is 2 divided by 2 gives me a 1, so it's just a 1. All right. So we have it. Those are our midpoints. Let's see. That's next page? Yeah, this is next page. Okay, so we'll go ahead and stop this one here. This is part 5. I'll see you guys in part 6. We're going to be, looks like we're going to talk about some characteristics of some shapes. See you guys in a few minutes.